Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson on a brief history of quality. Part 1. In this lesson, we cover some definitions regarding quality, and we'll cover an introduction to some of the leaders of the quality movement over the last 100 years, and we'll go over some of the prominent approaches and systems in quality management. What is quality? Everyone thinks they know what quality is and that they can recognize it when they see it. However, different people have different ideas on what quality is, and it can be a struggle to come up with a single unifying definition of quality. Here are some famous definitions of quality from some different quality and management leaders. W. Edwards Deming said that quality is what will sell and do a customer some good. Joseph Juran said that quality is fitness for use. Philip Crosby is famous for defining quality as conformance to requirements. Peter Drucker said that quality in a product or service is not what the supplier puts in. It is what the customer gets out and is willing to pay for. And then in the ISO 9000 series of standards, we have the definition of the degree to which a set of inherent characteristics fulfill requirements. And this is the definition that the PMBOK guide uses. The quality leaders that we'll introduce in this lesson include Walter Shewhart, W. Edwards Deming, Joseph Juran, Kaoru Ishikawa, Philip Crosby, Armand Feigenbaum, as well as Eli Goldratt. We'll start with Walter Shewhart. Mr. Shewhart is known as the father of statistical quality control, and was the one who introduced in 1924 the concept of a control chart, in which you graph the outputs of a manufacturing process on a chart, and use that chart to help identify whether a process is in statistical control or not. He identified two different kinds of variation in a process: assignable causes and chance causes. Suppose you have a manufacturing process that creates ball bearings. The diameter, the exact diameter of those ball bearings will never be exactly the same from one to another, but it should be pretty precise and within a certain degree of tolerance. Now, the process itself will have a certain amount of natural variation to it that really can't be controlled without significantly changing this process, and that randomness or variation is known as chance cause variation. However, there may be other factors that are assignable causes, and these are influences that change the output in ways that you can better control. So, for example, you may find that the ball bearings that are manufactured at night during the night shift are larger than the ones manufactured during the day shift. And so there's something going on with how the people or machines or processes are being used at night that is different. And that's an assignable cause that you should investigate and eliminate. And the whole goal here being to minimize variation in order to improve quality. The more these parts are close to being exactly identical, the longer they're going to last, the better the quality of the components that are built using these parts. Shewhart is also credited with having invented the PDA cycle, or the Shewhart cycle, the plan, do, check, act cycle. And he worked with W. Edwards Deming, who gathered a lot of information and insights from Walter Shewhart. Shewhart also published a book that you can see here in the corner, entitled Economic Control of Quality of Manufactured Product. This is an interesting historical read if you have a pretty good background in in statistics. Otherwise, it's a pretty difficult book to read, and you may get more value out of some of the other books that we mention here. Next, we have W. Edwards Deming. He's considered the father of the Japanese quality movement. After World War II, he went to Japan and taught statistical process control, and there championed Walter Shewart's work and was instrumental in introducing the Japanese manufacturing industries to these statistical process controls, which they then used, and over time were able to improve their manufacturing to the point that we had this Japanese manufacturing crisis in the US, in which US manufacturing was threatened because the Japanese were manufacturing cars and things to much better quality standards. W. Edwards Deming is also credited with the Plan, Do, Check, Act, or PDA cycle, but he actually credits Shewhart with having invented this cycle. W. Edwards Deming is famous for his 14 points, which are some management principles that he outlines in his book, Out of the Crisis. Unfortunately, he was very much underappreciated in the United States until he was discovered in 1980, at which point U.S. manufacturing started to take notice and adopt some of these quality principles. And he's the one who said, "Quality is what will sell and do a customer some good." His book, Out of the Crisis, is a very interesting book to read, has some valuable insights. It is definitely somewhat dated, but still interesting and valuable. Joseph Juran, on the other hand, focused on quality management, on the responsibility that management has for quality. He's the one who popularized the Pareto principle, or the 80-20 rule, and wrote about the cost of poor quality. He's famous for the Quality Control Handbook, which was published in 1951. He spent some time teaching quality management in Japan, and he taught that resistance to change is the root cause of quality issues. He also brought quality circles from Japan to the United States in the 60s. From his perspective, quality is defined as fitness for use. Kaoru Ishikawa is famous for the Ishikawa diagram, also referred to as the fishbone diagram, and in the PMBOK guide it's referred to as a type of cause and effect diagram. He introduced the concept of quality circles in Japan in 1962, and he is noted for having translated and spread throughout Japan the work of Deming and Juran. You can read more about his principles in his book, The Guide to Quality Control. Philip Crosby was famous for focusing on zero defects as the goal for improving quality, and published his book, Quality is Free, which is based on the idea that if you do it right the first time and build quality in up front, that you'll actually end up spending less money overall to get a quality product than you would have spent to not spend this time on quality and end up with a lower quality product. His definition of quality is conformance to requirements. Armand Feigenbaum was famous for total quality control, and his book entitled Total Quality Control, as well as Total Quality Management, which focused on accountability and on getting the entire organization involved in quality. And he introduced the concept of cost of quality, or COQ. Eli Goldratt introduced the idea of the theory of constraints in his popular book, The Goal, published in 1984. In the theory of constraints, the focus is on the system's bottlenecks, or constraints, as the key element to improving a system's quality. A common theme in the modern quality movements is that we should be focusing on prevention over inspection, which is based on the observation that the cost of preventing mistakes is generally much less than the cost of correcting mistakes. Prevention is all about keeping errors out of the process, whereas inspection is about keeping errors out of the hands of the customer. Hundreds of years ago, quality was managed by guilds that would learn and pass on processes and techniques known as trade secrets. Then, with the industrial age and with mass production, we got into the bad habit of focusing too much on inspection to make sure that products were of high quality before they reached the hands of the customer. Then, with the modern quality movement that started about 100 years ago, we started focusing more on this observation that if we spent more time up front on preventing errors by improving the processes, that we could have more consistently high quality and generally at lower cost. This graph may help you to visualize how the cost of changes over the life cycle of a project. Early on in the project, when you're first defining the requirements and designing the product, making changes at that point is much less expensive because you haven't started building anything yet. As you move along in the process, the more you start to build, if there are changes, then you have to go back and redo some of your processes. You may have to rework some of the work that you've done. And then toward the end of the project, making the same change that was small at the beginning could be a hugely expensive change toward the end of a project. The same goes for quality. If you build quality in from the beginning, you are less likely to have to rework it or change it at the end. And so your costs for quality are lower if you take care of it at the beginning rather than at the end. The cost of quality is the sum of all costs incurred over the life of the product. What's important here is that it extends beyond the project and covers the entire life cycle of the product itself. It includes all of those activities for prevention of errors, the work and cost involved in appraisal to determine whether or not your outputs meet quality standards, the cost of reworking things that don't meet your quality standards, and your warranty costs, or those costs that after you've shipped to a customer, you have to incur in order to fix mistakes and problems after the customer has received the product. These costs of quality are further organized, as you can see here, into the costs of conformance and the costs of non-conformance. Costs of conformance include preventive costs, such as training and documentation of what the processes should be, like standard operating procedures, money that you spend on getting the right equipment, and the time you take to do things right the first time. These are all preventive costs, building quality into the product. Appraisal costs are about assessing the quality and include things such as testing, including destructive testing, which means that sometimes in order to test, for example, the strength of a bolt, you might actually have to break the bolt to see at what point it breaks. These are known as destructive tests, and they have certain costs, as well as other types of non-destructive inspections. All of these costs of conformance are money that you spend during the project to avoid failure later on. The costs of non-conformance include internal failure costs and external failure costs. The internal ones are the ones that you find during the course of your project and that require you to either rework or scrap some of the work that you've been doing. External failure costs are those found by the customer. These are the worst, and these involve liabilities and warranty work and can cause loss of business and loss of market share because of lost reputation. All of these costs of non-conformance are the money that you spend during and after the project because of failures that have happened. You need to be familiar with these terms, their meanings, and how they relate to one another. And now it's time for a bit of a quiz to test you a bit on some of the leaders of the quality movement. And not only on what you know so far, but on how well you can make some inferences or deductions based on what you already know. Let's start with this one. Who was it that invented the Plan, Do, Check, Act cycle, the PDA cycle? Here's another clue. Who was it that is considered the father of modern statistical quality control? The answer is Walter Shewhart. This may not be what you expected. Most people think of Deming when they think of the PDCA cycle, but Deming attributed this cycle to Shewhart. Deming adopted and popularized and taught a lot on statistical quality control, but he derived much of this from Shewhart, who was a mentor of his. Here's another one. Who said that every successful quality revolution has included the participation of management? Would you like another clue? He also said that for many phenomena, 80% of consequences stem from 20% of the causes. If you're still not sure, this last one should give it away. He also described quality as fitness for use. The answer is Joseph Juran. He taught a lot about quality management, introduced the Pareto principle, and described quality as fitness for use. And now let's move on to our next quality leader. Who is it that had 0 defects as their motto in quality management? How about this one? Quality is conformance to requirements. If that's not enough, this one should give it away. Quality is free. It's not a gift, but it's free. What costs money are the unquality things, all the actions that involve not doing jobs right the first time. The answer is Philip Crosby. He's the one who wrote the book Quality is Free, and is the one who popularized the idea that quality is conformance to requirements. He also talked about doing things right the first time and focusing on 0 defects as your goal. Now, who was it that was instrumental in introducing quality circles? How about the person who is famous for the fishbone diagram? The answer is Kaoru Ishikawa, who's famous for the fishbone or Ishikawa diagram, and also introduced quality circles in Japan. Next, we have the quote, "Total quality control is an effective system for integrating the quality development, quality maintenance, and quality improvement efforts of the various groups in an organization." The answer is Armand Feigenbaum. The key here is to focus on total quality control, which is the title of a book written by Armand Feigenbaum. How about this quote? "A bad system will beat a good person every time." Or this one, "Without data, you're just another person with an opinion." You won't have seen those two before, but what about this one? "Quality is what will sell and do a customer some good." These were some pithy quotes from W. Edwards Deming, who said, "What you have learned is that the capacity of the plant is equal to the capacity of its bottlenecks. That would be Eli Goldratt. He's the one who wrote the book The Goal and introduced the theory of constraints, which is based on identifying bottlenecks in the system and dealing with those bottlenecks. This is the end of part 1. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.